we are going to continue looking at what happens when we add something to the outside of our absolute value. So notice that this was a -4 on the outside of the absolute value, but here we have a +4 on the outside of the absolute value. So what we're going to do is we're going to, again, write in what the parent function is, and I'm going to say the function that I'm looking at, the very basic function is the absolute value of x. That's my parent. Nothing special is happening. So I'm going to ask myself, what is happening to this absolute value equation? So on this absolute value equation, I have a +4 happening on the outside of the absolute value. So this might indicate to me that I have a vertical shift on the outside. So I'm just going to write here, because it's on the outside, this is going to give me a vertical shift, okay? And it's most likely going to be up 1, because on the outside it's the same. Getting ahead of myself. So let's go ahead and figure out what our vertex is. Notice I haven't even graphed it. I should be able to figure this out just by looking at the equation. Nothing is being added to the x on the inside of the absolute value. So that means I have a 0 here. X minus 0 gives me x. On the outside, I have a 4, a positive 4. So notice here, this gives me my vertex. So this is going to be 0, and this is going to be 4. So my vertex should be at 0, 4. The other thing that I remember is I can get my axis of symmetry by looking at my 0, or my x value right here, my vertex rather. So that means that x equals 0. And because the vertical shift on the outside is the same, that means that this function should go up 4. Okay, so I was able to determine all of that just by looking at the equation. I didn't even have to graph it. But let's see if I'm right. So I'm going to go ahead and I'm going to take my calculator, and in my y equals, on the outside of that absolute value, I'm going to make that a +4. I'm going to look at the graph. When I look at the graph, I see, oh wow, it did. It moved up, didn't it? In fact, I'm going to change the, how I was kind of close. So you can see it moved up from the parent, because the parent started down here, and in fact did go up 4. So again, we can go to our table and we can get all our values from here. I know that this went up 4 from the vertex of the parent, 1, 2, 3, 4, and nothing else happened. Nothing happened in the inside, so there was no horizontal, and nothing else is happening but a +4 on the outside. So I know pretty much that it's going to take the same shape. And what do I mean by that? Notice that this goes up 1, right 1, up 1, right 1. So this is going to do the same, up 1, right 1, up 1, right 1, and so forth. If you don't feel comfortable doing that, you can always look at the values in your table. This went up 1, left 1, up 1, left 1 on the parent, so I can go up 1, left 1, up 1, left 1, up 1, left 1 on the transformed function. Okay? So again, because this is the function I'm concerned about, I am going to go ahead and make that a solid line. I am going to label this parent function. So what was the transformed vertex? This vertex right here, that's our vertex. I'm going to write it down here. That's our vertex, and that's at where x is 0 and y is 4. as I had indicated up here, and that my axis of symmetry goes through the vertex. So since it goes through the vertex, in this case, it happens to be the same as my y-axis. It's kind of hard to see. So I'm just going to use maybe a highlighter to make it a little bit wider. Okay, that's my axis of symmetry right there. So I'm going to call that my axis of symmetry, and that happens to be where x equals 0. It's not always the case, it just is in this case. And my function went up 4. So my graph is showing that everything I put here is correct.